Hello, this is my English speaking practice and I'm working on coding programs. Yep, today's first question problem is find peak element. Let's go. A peak element is an element that is strictly greater than its neighbors. Given a zero-indexed integer array nums, find the peak element and return its index. If the array contains multiple peaks, return the index to any of peaks. You may imagine that nums the last element of nums and the last element nums is negative infinity. In other words, an element is always considered to be strictly greater than a neighbor that is outside in the array. Okay. You must return an algorithm that runs in log n time. Log n time. Okay. Yeah. Let me think through this. So the last element would be negative infinity. In other words, our element is always considered to be strictly greater than a neighbor that is outside the arrays. This means the left one to the 0. Yeah, I'm confused because -1 and can specify the last index in Python, but what it says here is the outside of the arrays value is negative infinity, so the element is always considered to be strictly greater than the neighbor that is outside the array. Okay, I understand. And the peak element is an element that is strictly greater than its neighbors. So yeah, there might be multiple peaks, right? And we return the index to any of the peak. Okay, I see. So in this case, numbers is like this. So the left outside of the array is negative infinity, and this is also negative infinity. So the graph is like this, and the peak is this. So the index is 2. Yeah, 0 indexed integer array. So the peak, the value is 3, and we should return 2. Okay, and this case 2 is also good, and 6 is also good. Yeah, let me see the explanation. Your function can return either index number 1 where the peak element is 2, or index number 5 where the peak element is 6. Yeah. Yep, I get the problem, and the constraints is like this. Okay, and this is important information. So for all valid I, the consecutive numbers are not the same. Yep, I think this is important. And the length is not too large, but we are required to write an algorithm that runs in log n time. So yeah, we will do something like binary search, or yeah, like that. Mm-mm. So how about how to, yeah. Let me think. Let me think how to start it. Mm, mm, mm. First, since the number is not sorted, and we cannot sort it, so the binary search won't work, right? We cannot sort it. Yeah, that doesn't make sense. So we will look at the original arrays. Let me think about this example. 1 2 1 3 5 6 4, and we have two 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 answers, and either is fine. mm, we have to look at the peak. mm. Yeah, if we can find the maximum value, that must be the peak. Yeah, because that is the maximum, and the consecutive numbers are not the same. So yeah, it assures the maximum value is peak element. Yeah. So yeah, I think this might be the key idea. Mm, hmm. Mm, how about separating two parts? Mm, I don't think that's good, because not sorted, so that doesn't make sense. Yeah, but the we can. Mm, let me see the approach. Like, we have two pointers and the middle, and we compare them, and we can yeah, we can check the bigger one. For example, we have 1, 3 and 4 for the first time, and the 4 must be greater than the right side, its right side, and the 1 is also greater than the left side, and we have to compare this one and this one. No, we don't think about this because the maximum number is 4, so we choose 4. We look at 4, but the 4 is not the peak because 6 is larger. 6 is larger than 4. Okay. I understand. So for the number at the both sides, it must be greater than the other one, because the number outside the array is negative infinity, so we have to check the other one. For example, and if it's not peak, the left one or right one should be larger than the current value 1 or 4. So, and it's good to find the maximum value at the time, but the worst case is like 1, 2, 3, 4, 5. So increasing this direction, and for this is increasing 5, 6, 7. So this case, yeah, I'm thinking about the worst case, because when we look at this, we have to check at the next one. Okay, and yeah, and this case we have to look at this one and this one, and have to look at this one and this one. Yeah, so that means peak must be between them, because yeah, as you can see, the number is increasing and decreasing. So I think this is the key idea, and the problem is how can we find the peak in this situation, and we cannot look at one by one, because that would be the linear algorithm. So yeah, that's log n, not log n, that's O of n solution. So we have to improve it, so we cannot look at one by one from the side. Okay, so yeah, this is a normal good case, and this is like a edge case, but we have to we have to avoid the linear algorithm even if we handle the edge cases. So we cannot see one by one. Yeah, how to do that? Yeah. So in the worst case, maybe we can do like binary search because the numbers are sorted. Yeah. So the peak is like, yeah, for example, peak is 15 or like that. And okay, I see. So this case, we look at three numbers at first, and look at the next number, and if that is greater than the current one, we can move on to the next step. What do we expect? 3 is here, this is 6, and this is 2, so both of them not good, and the peak is 3, and 6 is greater than the 3, so we are focused on the right side, and still we have unknown values between them, but there is a there must be the let me think about x, and we have 3 cases. This case, and yeah, this case, and we have some values between them. Let's assume some values between them, and so it might be like this, and I'm trying to figure out yeah, to figure out how to prove that there must be the peak value. So in this case, 6 is greater than 4. Yeah, I get the information. So the 6 expects the smaller ones, okay, and yeah, so when we move on to the next step, this value is greater than 6, okay, because if the value is smaller than 6, we don't need to think about the case because we find the peak that is 6. So when we trying to move on to the next step, the 6 is not the answer, so the value would be larger than 6. So we can prove there must be greater value than 6. Yeah. And for this, we can think it for the same way. So there must be greater than 4, okay? So we can narrow it, and the value would be increasing. Yeah, that's it. I think that's it. Wait, but how can we okay, how can we narrow it? Let me think about the solution. So for the first step, we can narrow it as half. We can take but it's not the problem, because if we take this, I see. So what we have to avoid is the case where the number is increasing in sorted in ascending order. And this example, if there is two elements between them, we can make sure there must be peak, because no successive numbers and the value is it's contains negative value, okay. But yeah, in this case, Oh, negative value. There negative value. Wait. What I was thinking is one something 3, and we have to avoid this case because that we cannot find the peak. But for example, like this case, we have 1, 2, and something and 3, and there must be no consecutive numbers, so 2 and 3 never appears. So yeah, except for 2 and 3. So might be 1, might be 4, or negative infinity, or too large, large value, or anything is okay, because there must be peak. We must find the peak. So the important thing is to avoid the increasing arrays. So we have to check the number of items and the value of both sides. Okay, this case the difference is 2, and we expect in this case 2 is not good. 2 minus 1, we 3 minus 1. Okay, in this case we the number of element is expected more than 1. Okay, like this, because it's I mean, so we have to subtract 1 from the difference, and that is when the number of element between them is this number, we cannot find, there is a possibility not to find the peak element, so we have to avoid it. So this case we need okay, so in this case 3, 4. Oh, that's so good, because 4 minus 3 is 1, and we subtract 1 from it, so the number is 0. So we cannot so in this case we make sure there must be peak. there must be peak. So let me think about this case. It's one and four, and for example, this case. We look at 1 and 4, and we look at 5 as a middle value, and for left side the difference is 4 and there are 3 elements, so we cannot find the peak in the left side because there is a case we cannot find the peak. Yeah, this is edge case. Yeah, we have to know, oh, that is not good, so we are going to look for the right side. Yeah, and right side is good because the difference is 1, so there must be peak as long as there is one element between them. Yeah, that's it. So we can solve this problem with log n, logarithmic algorithm. Yep. Okay, let's code it. So we use left and right pointer and like this, and there must be peak element. It doesn't mention it. Oh, there must be, because if the array is sorted in ascending order, the last element is the maximum value, and yeah, the maximum value must be the peak because yeah, it's obvious. Yeah, we can find the maximum value in the arrays, so there must be peak. Okay, I see. So middle is we compare and we compare the values and number of items between them. So for left, absolute value, middle minus left, and minus 1. No, minus 1. No. In this case, how about this? The absolute value is 6. So we can 1, 0, minus 1, 2, 3, 4. So this case, this result is 6 and minus 1. I'm not sure the proper variable name, but distance means the difference of indices. So middle okay. So let me see, difference means 6. I'm confused. Difference is, so we must avoid, we need element more than 1. Okay, so diff is the baseline criteria. So we need element but this distance cannot represent the number of elements. We have to yeah. The condition is like this, so we can remove this negative 1 and for example the diff is 6 and the distance must be greater than 6, so because 1, 2, 3, 4, 5, 6. Yeah. If it's the same, we can make the ascending or descending. That means we can make sorted arrays, so that's not good. So the distance must be greater than diffs. Yep. So if this condition meets, we can look for the left side. So that means narrow it and right. But the side must be greater than left side, so we can check the left plus 1, and that is less than left. We can return L as the answer. Okay. And we do it for the right side. Yeah. And we have to make sure we will reach here or here. For example, I made a mistake. The condition is opposite. if the diff is 6, distance, it's correct. It's correct. For example, this case, diff is 6, so the distance 0, 1, 2, 3, 4, 5, 6, 7. We need to add two more elements. So how about this? And we can make sure there must be peak, and I'm not sure this is not good. Yeah, we have to check both sides. But for the first time, that is edge case, we can that have negative infinite. But for normal case, for example, when we look at the middle -5, and let's move on to the next step, this would be the right, but this value might be 6, so we have to check both of them. Yep. So yeah. To handle edge case, and Yeah, I think it's almost done. And let me test it. Yeah, correct. We get correct answer. And let me see the edge cases. The nums is nums length is 1 at least. Maybe we cannot cover it when the length of numbers is 1. We return 0. And how about the length is 2? M is also 0, so it's not good. The bigger one is the answer, so return 0 as a default. And okay, and let's think about there are 3 items. We can get 0, 1, 2, 0, 1, 2, and middle one we can check middle. And for left is 0. Yeah, we can check the right one. Yeah. How about 4? 1, 2, 3, 2. Left, middle, right. In this case, left, right. The distance is 0. No, distance is 1, but the diff is also 1. So we should look at this and the diff is 0 and the distance is 2. So we can look at this and we check 3 of them. We check all of elements in this range and we find 3 as the answer. That looks work. It take long time, so okay, I see. Oh, I see. So we cannot update the index because the difference is 2 and also distance is 2. Exactly. We cannot handle this case. Yeah. So we can make sure there must be the answer. So if wait, but let me think this button. Yeah, this is in this case we can find 0 at first. In this case, -1 is not the answer, and we have to look for this part. Look at this and look at this. Okay. But in this case, yeah, this range doesn't meet condition because this part might be -2, -2. But in this case, -2 is here, so we should look for this part. But I cannot understand the process to decide which one we have to look for. Is this coincidence? No, that's not. For example, how about this? Yeah. This could be. So this condition doesn't work. There must be correct condition. We can look at left, middle, and right. In this case, distance must be thinking about how to reason it out. reason it out. So my solution is the solution is to identify the range where the peak is. So, but the problem is the condition is too strict, so there is a case when we cannot update the condition and we cannot update the range, so it causes infinite loop. That is a problem right now. And this is the one of the case we cannot handle right now. We look at -5, -1, and -3. Because in this case, this can be -2, so we cannot find peak, but in this case the answer is, oh wait, in this case the answer is this. So it's not independent, I think. And also this example is too small, so we cannot find the pattern from it. So I want to say how about this? Their diff is 4, but there is 2 elements, so this is not good. This is also not good because diff is 5. Okay. I see. So maybe we have to what? Okay. Negative. In this case, okay, so we have to check the number. Okay, middle and left, because yeah. Diff and distance is not correct. So when we move on to the next search, it expect yeah, it expect the left one is the smaller. Left one is the smaller, so we can compare this one. Yeah, this one is middle or more. Yeah, there must be peak. Yeah. So we have to go for left. the right minus 1 is first we have to compare the middle and left, middle and right. Yeah. Because left and middle and right. Left minus 1 is oh wait. Okay, this is not enough. Okay. We compare left and middle, and left and middle and right. 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 Oh, we cannot identify. So when the middle is not the peak, the right next or left next is greater than the middle, so it's time to finish. Let's see the solution. Really? Just look at the middle, and the middle is greater than the next to the middle. We are going to left because middle one is greater than. Okay. And in this case, Mm. In this case, there is one counter example, like increasing monotonic increase, but the next to the middle is less than the middle. So this case, the middle is the answer, will be the answer. Okay, and otherwise, look at the middle, and next to the middle is greater than the middle. In this case, we look for right side, and yep. Oh wait, but this case and this, there's two patterns, and this is also two patterns. But this case is left side is the answer. Yeah, it's correct. I see. Okay, let me explain. This solution. From the start. A peak element is an element that is strictly greater than its neighbors, and given a zero-indexed integer array's nums, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. You may imagine that nums at -1 and nums at n equal to negative infinite. In other words, an element is always considered to be strictly greater than a neighbor that is outside the array. You must write an algorithm that runs in O log n time. Okay, got it. And there is a constraints, and the number of values might be negative and positive, and the consecutive numbers values are not the same. Okay, so we can now let's take a look at this example, and the problem requires us to solve this problem with in the O of log n runtime complexity. So yeah, we will use like a binary search. So we have to narrow the range to search. Okay, so that be the basic idea to solve these problems. And for this, yeah, let me think. We have to do like binary search. We look at the left side and right side and middle side, and I think the key might be decide which side we have to look for next step. So in this case, we look at this side and this side, and we can make sure there must be the maximum value in the array. So so the maximum value would be the answer. So basically we have to find it. Yep. Yeah. So when we look at middle value, that might be the peak. Might not be the peak. Yeah, whatever. When that is the peak, that's okay. And when it's not the peak, there must be the larger value next to it. Okay, so basically we have to go for it. For example, this case, we look at 3, and this is not peak value because the 5 is larger than 3. So we look for the right side, and yeah, and there is a case that is not peak. That range doesn't contain the peak value. Oh, no, that's not. Because if the 5 is not the peak, there must be big, and must be big, and must be big. Okay. So this is an edge case. Okay, but for this is, in this case, the most right value would be the answer, because the number that is outside of the array is regarded as negative infinite. So yeah, the h is the peak value. So if the numbers in array increasing, just increasing, we can find the answer. Yeah, and also in other case, if not increasing, they must be decreasing point. Okay, so for example, like this. So when we look at middle and the middle is not the peak, we can decide which one we should go. Okay. For example, if they are both of them are larger than the middle value, let me think. This case, 6, 3, and let's think about the edge case. Edge case is just decreasing. Example 9, 8, 6, 3. This is one of the edge cases. But in this case, similar to this case, the 9 is the answer. 9 is the peak value. Okay, and when it's when there is a increasing point, there must be the peak value. So the point is, when we look at the middle and it's not the peak value, we can decide which one we should go. So and there are 2 patterns: just increasing or contains peak. but just increasing is is the edge case, but we can looking we can go for the right and right, and we will reach to the end of the array, and we can identify that is the peak. This is the solution, core of this solution. So let's implement this solution. Middle index is like this, and here we want to check if the middle value is the peak. So but we don't need to wait, because we have to be able to go to the leftmost and the rightmost, so we have to think about it. Handling in the indices is not easy to implement. So when we look at middle might be the 0. Middle might be the 0, so we cannot use middle -1. So we just check middle and middle +1. So we don't check if the middle value is the peak or not at this time. Really? That makes sense to me. So the basic is like just compare like this and check, decide which one to go. Middle, in this case we have to go for right side, so the left be the middle, and otherwise right would be the middle +1. Middle +1, because middle +1 is larger, so this value never become the answer, so the L is n+1, and otherwise go for left side, so the right bound would be the middle. Okay, and we look at this. this one, this one, this one, yeah, this one, this one. So finally, how about this case? Like this, because when we choose this one and this one, the middle might be point this, and when the middle plus 1 is larger than the middle, yeah, the left bound would be the rightmost. So we have to consider the final left and right. So the answer will be like this. I have to use L and right, not M in this case. Great. Great. So simple. Yeah, I wish I could solve this problem for the first time. I still have time, so let's go to the next. Okay, let me see the English phrases today. I'm going to use new phrases. Yeah, let me think through this. And I think the key might be, let me see the approach. Like, I'm trying to figure out, maybe we can start with a simpler case. Let's see what happens if it might make sense to. I'm not completely sure, but my intuition says I might be wrong, but let me try this first. I'm thinking about how to optimize this part. Okay, let's break it down step by step. I will start by defining the base case Now I'm gonna handle edge cases. Then I will move on to the main logic. Let me test it with a small example. Okay. Let me see. Let's see what happens if. Let me think through this. I'm trying to figure out. Okay. Let's go. Maximum gap. Given an integer array nums, return the maximum differences between two successive elements in its sorted form. If the array contains less than the two elements, return 0. You must write an algorithm that runs in linear time and uses linear extra space. Okay. Let me read the statement again. The maximum difference between two successive elements in its sorted form. If the array contains less than two elements, return 0. Oh, let me see the example. 3691. Output is 3. The sorted form of arrays. First, we should sort the array, and we check the maximum difference for each successive elements. I see. If the array contains less than two elements, it means the length is less than 2. Okay, I see. And we have to write an algorithm that runs in linear time, so we cannot use sorting function. Sorting function takes n log n, so we cannot use it. Okay, but we can use linear extra space. Okay. Let me think through this. So we cannot sort it, but we can memo it. So, and the difference. So we have to keep track of numbers we have already met. Really? Maximum difference is 3691. 3, 2, 3, 6, 3, 6, 9, 3, 6, 3, 6, 5, 3, 6, 9. The value is 10 billion. No, 1 billion. 1 billion at the most. So we cannot use value for the index. Yeah. Okay. I see. Linear extra space. Hmm. It's difficult. Oh, but let me start to think about iterating through nums, because we have to solve this in linear time. So basically, yeah, we will iterate through the nums from left to right. Yeah. So look at 3, and when we look at 6, we can calculate difference as 3, and when we look at 9, we have to look at 6 and 9. The difference is 3, not changed. How about this case? The answer should be updated to 2. Yeah. So should I keep track of minimum and maximum values that already appeared? And when the new number, coming number, is between them, I don't know. Too big. So I'm thinking about, is it enough to keep track of minimum and maximum? So in this case, we have 3 and 600, and 100 is so the maximum difference is 500, and yeah, and when the 500 comes, should be updated to 400, okay, because this part is the maximum difference, but if we don't have 100, because it's not minimum and maximum, we cannot get the 400. Yeah, that is the correct answer. So it's not enough minimum storing, keeping track of minimum and maximum. That is not enough. Oh, I understand. So we have to return the maximum differences. So we have to 160, yeah, because this is also not good, because for example this part is 500, so let's say 500, so this case, and we get this. This is the current maximum difference, it's 500, and we just have these values. The minimum is 100, but actually there is minus 300, and we get minus 600. So yeah, it's still 500 as the correct answer, but if we don't keep track of this value, the maximum difference would be minus 700. Yeah, that is not correct. So the negative minimum value to be kept track of minimum value to store. So I think these three values are enough. Because yeah. Oh wait. No. There is a case. Example 400. So there. In this case, okay, we have to store four values. Maximum range maximum difference. The numbers that forms maximum difference and minimum value and maximum value. Oh wait, we can use linear extra space. So something wrong. We can use linear extra space, so maybe this is not enough. Let me think. For example, the difference is 4 and difference 3, and this value is middle of this, that is split into two parts, so the answer would be 3, but we cannot keep track of these values, so we have to we have to store all of values. But how to update maximum difference in constant time? Oh. Okay, let me see. This case, yeah, in order to update this value, that can or when the x meets this condition, the maximum value would be updated because the difference would be greater than 3 on this and this. And also in this case, the difference, even the difference is less than 3, but it breaks the current maximum difference. So this is also the condition. When the 9 comes, condition doesn't change because 9 doesn't meet condition. But when the 5 comes, it meets condition. Be the 5 and 6, 8 and 1. Yep. So so every time we have to update the maximum difference in constant time, so we have to able to check if the value can update the maximum difference. So we should have conditions. But sometimes there are multiple conditions, lower bound and upper bound, and in the middle there are several conditions. Could be several conditions. Yeah. Yeah. Okay, I see. So maybe we have set to hold the number, and we can access the value in constant time, and So this case 3 and comes 5. The when we put the 5 onto the list that holds the numbers that appeared, the 5, we should calculate 5 minus 3 and 5 plus 3, and that is 2 and 8. Okay, and but how? It's oh difficult. Cannot do it. But the idea that that calculate the difference based on the coming number, and 2 and 8, 2 and 8, and let's think about this case. There are differences, and current maximum differences is 10, but there might be broken, and there are some candidates for next maximum differences, and oh, Let me think. Nouns value is the key or hash map is the key is hash map sorted or is the key of hash map sorted? Let me okay. Sorting is not the key. Getting stuck. But I'm thinking about iterating through once, and we process it somehow, and we iterate through one more time, or something like that. So we can difficult, but I want to solve this problem. Um, give me a moment. Linear extra space, so we can use hash map or set, and for the first, after the first loop, we can identify the range, mix and max, minimum and maximum, and the first maximum difference is this, and for all elements within this range, so the maximum difference is going down. So for example 3 and 5 or like that. Yeah. And how to update this? We have to keep track of this one, this one, this one, this one, this one. Split it, split it, split it, split it. How to? let me we use key value store dictionary, and the key is index. That is key is value. It's confusing. For example, okay, in this case the minimum value is 1 and the maximum value is 9, and so as an initial state the key is 9 and the value is 8 because the maximum difference is 8. That is made by 9. Okay, yeah. Oh wait, let me have the starting index and the maximum difference, and it's not good. Because we cannot identify which one should be updated. For example, when we look at 3, the 3 is like this, but we cannot update this. In constant time, because when we look at 6, we cannot get these values in constant time. So yeah, this is expected, but we need to know there is 3 and 9 is also updated, should be updated. I think the key is to update the maximum difference in constant time. But that is very complicated. There is a lot of patterns. Yeah, change the way of thinking. We want to sort but we cannot sort in linear time. So instead of sorting, but it needs to find the successive elements, but it's impossible. Yeah, it's impossible to do that in constant time, because there are a lot of numbers cannot find. Becomes 9. I'm thinking about updating maximum difference. So this case, the maximum difference start with 150, and we get the random value between them. The problem is we can update only the current value. That means we cannot update the values that already appeared. So for each, yep. Basically, we are look for bigger side, but sometimes when the bigger one is separated, the bigger one another area becomes bigger one. Okay, so how to manage this? When we update here, it needs to know this point and this point, but it's not impossible in constant time. Yeah, this is a problem. But for the bigger one, we can keep track of these numbers because that is involved in bigger, larger area, and we keep track. We are updating maximum difference and also update the both sides value at the both sides. Okay. So for example, for 8, 5, we keep track this part, but when date like this. Can we store this? No. Maybe we can store, but we cannot find it in constant time. Yep. This is a case I'm thinking about. For example, seventeen divide it. Well, if we use heap, it takes log n for each insertion, so that doesn't work. Updating maximum is not good. We have to Is there any hint? No. Topics is bucket salt. I forget the bucket salt, but it can be sorted by linear time. And it uses linear extra space. Yeah, that makes sense. Bucket sort, but how to do that? I forget the bucket sort algorithm. Let me think. Bucket sort. What is bucket salt? I heard of it. Yeah. I think that maybe that it uses values for the keys for the index. So in this case, the value is larger than number of length of numbers, so we cannot use it. Yeah. If we can do like this, that makes sense. But the length of numbers is but length of numbers is less than the max values, so I'm not sure this is allowed. But problem statement says linear, so this can be linear. The size is different, but it's linear. So I think, can I do this? If we can do this, that is very easy, because we just iterate through the numbers, and the bucket sort is like this. this is bucket and the I we should initialize. So that means the bucket key is the value, so we can no. And I might be those numbers, and but at the same time might be invalid value. If v if v is -1, not initialized at the number, so we cannot use it. And otherwise the v is the number that appears in this list, so we can is 0 and leave is if there is first v, prev v, we can update answer. Okay, that's the difference, and we update prev v, return us. Let's go. Memory limit exceeded, so this is not allowed. Okay, I see. So maybe this. I see. Really? Ah, not the V. Huh? Huh? What is it? Let me see. N is the number. N is the number, and we use it. And this I is not important. But we use it just to filter it. And the important value is I. Yep. But this causes memory limit exceeded. Okay, I see. So this solution is not good. Okay, but so from now I will reduce the bucket size. But how to where how to map it? I don't know radix sort. Bucket sort is like this, but we cannot allocate a billion items. I want to compress because there must be there are only 100,000 items, so we can use how to sort. The only way to sort it is to use the value as a key, as the index. But the value can be too large, so it can exceed the size of bucket. That is a problem. But the basic concept is like this. Use value as the index. So we have to map it. There's a lot of values. Mapping it. The value is not the problem. The order is important. Yeah, and after sort it, we can calculate them. Yeah, the order is important, and how to order it. How to compress. Difficult. How about divide by 10,000? Can be. V might be multiple. Since this is divided by 1,000, 10,000, so 10,000 at most. I feel like this is not beautiful, but I think I can. there is a value that is not negative 1, minus 1, we must have actual values as the key. We have to sort it again. Wow. I can do it. I can do it. But it's complicated. I can do it because we can compress it and the n range is between 10,000s. So we can manage the offset and its range. We can sort it and calculate the minimum value and maximum value and the maximum difference, and I believe I can implement this, but it's complicated to implement, so I think this is expected answer. but I can come up with idea to solve this problem, so I'm satisfied. I'm satisfied at a certain level. Somehow I'm satisfied, so I can see the solutions. Yeah. Maybe this idea is correct, but after that, I didn't come up with the clean clean way to implement the idea. So let me see. Min max gap is, this is average gap. And pocket circles. Is this correct? Oh. Oh. I thought this is not good because the value is too big, so this might be 10 billion, but divide by the average gap value, that can be compressed. Okay, and initialize. This is too smart. Instead of sorting the entire array, we can use the pigeon on hole principle. If numbers are evenly distributed, the number max gaps must be between buckets, not within. This allows for linear time bucket processing. Compute bucket size. Minimum. What? cannot figure out. Maximum is 16. Compute bucket size. What? Identify the global min and max, return 0 if all elements are the same. Okay. And calculate optimal bucket size. Bucket size. Min max. Is this gap? I thought this is average gap size. Yeah. Create bucket to store local min and max value. Traverse the array and populate each bucket. Scan through buckets, calculating the max gaps between consecutive buckets. This method avoids full sorting and cleverly uses buckets to achieve linear performance, a high impact optimization that can turn heads into gap +1. Oh. This is not n. This is gap. Yeah. For example, this case 150 ranges. 1, 2, 3, 4, 5, 6, 7, 10. There are 10 items, so 9 gaps. Let me like this. 10 gaps and 200 difference. So the average gap would be 20. That is a gap. And dividing by gap, we can calculate the items in this case 200 and average gap is 20, so we just need 10 11 because gap +1 11 9 or yeah. Anyway, we can compress. We can save the space, save the memory by dividing by gap. Yes. And yeah, we can identify the index using this is like subtract subtract offset, in this case 100, and this, in this case, this is gonna be index gonna be 0, index gonna be 0, gonna be 1, gonna be 1. Oh, okay, that duplicate might happen. There might be duplicate, and but we have two spaces, and oh, I see. Oh, this is so smart. So in my solution, I compressed by 10,000. Yeah, 10,000. But yeah, best way to find the divider is like this, and using this, we can identify the index, but sometimes it can be duplicate, and the duplicate might cause the problem, but this solution have two spaces. One is for minimum value, and the other one is for maximum value. And yeah, that is enough, because we calculate the maximum difference. So and between them, the maximum difference is within the gap, average differences. So I'm not sure this part. I understand this part. Maximum gap is buckets is sorted, so the max gap is minimum value of this bucket, and yeah, the difference is between minimum value of this bucket and previous max value. But I'm not sure. I want to for example, this case is the index 0 is okay, index 1 is 2 is like this, but my concern is because this is just compare this one and this one and this one and this one, but my concern is this is not included. My concern is like this. So this part is 9 and this part is 1, 5, 7. So this is the maximum difference. So I'm not sure. Average should be 20. Oh, in this case, the gap is 5. Oh, I see. But okay. But I cannot understand in intuitively. This is average gap. Average gap. Yeah, my question is why we just compare this case. Yeah. Maybe this is always true. Because the index is based on this. So if it's same index, the values are within the gap. Within the gap. But I don't know why this is always the answer. Why this is always answer? Oh, of course. And the gap is 5. 5 plus 1 because it must be within the gap, less than the gap. Less than the gap. exactly. Oh, I'm getting it. Getting it. Um, uh, 15 to 19. Yeah, 15 to 19. So, hmm? But wait. Oh, really? Oh, okay. This is average gap. Average gap. Um, uh, I understand. So, we assume there is average gap, and we divide it by gap plus 1, so the bucket is like this. And so I want if this value is move left, the maximum is like this. This index gonna be empty. And we can find the maximum difference like this. Yeah, this part never, yeah, this part must not be the answer. Because we we think about the average case and yeah, average case. So basically the maximum gap is start index starting minimum value at the index I and the minimum value at the index I plus 1. But in this case, in the normal case, one index contains one element, so this works. Okay, this works. And if there is unbalanced part like this, that means one of places how to say the place index I have two elements. For example, there must be place that doesn't have element. For example, this case, or this case, so if there is an empty place, the maximum difference is must be made by the max value at the index I and the minimum value how do I say, it's difficult to say even in Japanese. If there is an empty spot I with no element, the maximum value is the difference between the maximum value at the previous position I minus 1 and the minimum value at the next position I plus 1. Yeah. If there is no empty spot I without no element, that means the elements are evenly distributed with each position holding exactly one element. This expression is not familiar with me. That means the elements are evenly distributed with each position holding exactly one element. In that case, each element is both the minimum and the maximum value. Therefore, when we calculate the difference between the maximum value of the previous position and the minimum value of the next position, it becomes the maximum difference. Therefore, it's always fine to calculate the difference between the maximum value of the previous position and the minimum value of the next position. Yeah, that's why max gap is calculated in this way. This is so smart. This part is so smart. So this is gap. But this technique is useful when the value is too big. Yeah. Gap plus 1. Because the values are distributed like this, and calculate the average gap. Example, this is like this. Average gap is like this. And we prepare the bucket. And all of element can be inside in this and inside this place. And for example, this part, this part are likely to put in the first spot because they are close. The average gap is like this, so yeah. They are put into this, and and if there is, so it means if one spot have a lot of elements, there must be empty one. So we can find the maximum value like this. And all numbers can be can obtain the proper index like this. Because we have average gap. So that is this part is index 0, this part is index 1, this part is index 2. Okay. I understand. I understand. Submit. Hmm. Sort is not good. What is radix sort? Hmm. I feel like this is not related. Hmm. Suppose one was sorting these value pairs by their first element. Pseudocode. I see. So the first step would be to create buckets that have some ranges. Yeah, yeah, yeah. Into array I times k divided by m. M is the average value, average range, maximum key value in the array, key value in the array, maximum key value. What? Ah, I see. Radix salt is not related. Zero zero two two four five five six. Okay, I will finish.